Are you about to turn in your AM radio station license because you just can't make any money? Before you do, there may be options. There probably are options. Benjamin Dawson and Stephen Lockwood from Hatfield and Dawson Consulting Engineers are my guests on This Week in Radio Tech. We're talking about what to do with your AM transmitter site to make it valuable and keep it going. Coming up next on TWiRT. This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, savings, and support. Online at bgs.cc. By Broadcast Bionics with the Bionics Studio, including talk show control, social media, and visual radio. Broadcast Bionics brings exceptional audience engagement to radio and TV. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. And by Max Connect Wireless, prioritized high-speed internet service designed for transmitter sites and remote broadcasts. Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to that light bulb at the top of the tower. Hey, happy holidays, Merry Christmas, whatever you celebrate. We're glad to have you here. It's just a couple of days before Christmas 2021. I'm Kirk Harnack. I'm in the Telos Alliance studio in Nashville, Tennessee, surrounded by Telos Alliance gear behind the monitor, audio consoles and phone systems and everything. So great to have you along with us. Thanks to the Telos Alliance for affording me a couple hours a week to do This Week in Radio Tech. And I want to thank Suncast, our producer, because he's going to be a busy guy today. We've got a bunch of slides to show you from our guests, a lot of pictures, transmitter sites, and things to look at. So we're going to head right into the show, except before I introduce my guest, I want to remind you about this publication right here, Radio Guide. Ray Top publishes Radio Guide about 6 times a year, every 2 months, and Radio Guide is for us, engineers. It gives extra space for longer articles on how to do this, how to do that, how to think about engineering things, keep you informed and updated and excited about broadcast engineering. And of course, one of my favorite parts, where'd it go? I don't know. Did I lose it? You need to be reminded about This Week in Radio Tech. There's a big old half-page ad right here in the magazine. Thanks, Ray Top. You can go to radio-guide.com and see the online version. You can sign up for the paper version to get mailed to you 6 times a year at radio-guide.com. Thanks a lot, Ray Top. All right, we're going to roll right into it. We have a couple of industry luminaries, legends in their own minds and in the minds and hearts of many others. We have from Hatfield and Dawson, we have Ben Dawson. I get his name's in there somewhere, so there's got to be a story there. Ben Dawson the third is with us, and also Stephen Lockwood is with us. He's the president of Hatfield and Dawson. Hey, Suncast, do we have a triple shot? Can we bring them all in? There we go. Look at that. That is Ben in the middle. And that is Stephen on on the right hand of your radio dial up there at the non-commercial end. And I'm down here. I'm sorry, at the commercial end. I'm down here in the public band. So let's tell you what, I just did a show with Stephen a few days ago. So tell you what, Stephen, since you have the president title, why don't you introduce Hatfield and Dawson and introduce your colleague, Ben, for us?
Well, we're a consulting radio engineering firm, and we do, and I like to say, anything for a buck having to do with RF. We work in pretty much all services and have. So we have projects, AM, FM, TV, and then some high-frequency projects, and we do a lot of work offshore as well. So we're doing some high-power medium wave work in the Middle East, and we've got some HF projects with Uncle Sam working, and a few other interesting things like that. I have one partner who works entirely in the land mobile public safety world, so doing work for guns and hoses, as we say. But we're here to help you through your engineering problems with radio physics and propagation and allocation and other issues along the way. One of the things that we've seemed to have specialized over the years is in medium wave broadcasting, and that still takes a lot of our time. So good old AM radio, and it still remains a remarkably interesting engineering problem. But we're here to help.
So some people it's a problem, some people it's an opportunity, I suppose, and some people it's a place to write a check for. Stephen, and we're gonna introduce your colleague Ben here in a second. You have said this phrase "guns and hoses" about 5 times now that I've heard, and I finally figured out what that is. So this is police and fire, right?
Yes, absolutely.
First response. Okay.
Yeah.
I am so slow on the uptake.
I thought that was obvious, but yes, it's police and fire, and we even allowed the dog catcher to talk on these radio systems. So it's not just those guys.
Well, tell us about your colleague. I've not met Ben in person.
Well, Benjamin is certainly one of the forces behind this firm. The two partners, Jim Hatfield and Ben, started the firm up in the early '70s as sort of a carry-on firm from the firm that Jim Hatfield Sr. started in the '40s. And but they continued to practice for a number of years, doing the work. Ben has been someone who's published a lot and presented a lot of papers, and together with Ron Rackley won the Engineering Achievement Award one year at the NAB, and he's just been a fantastic colleague, friend, and mentor over the years, and he's.
We've probably talked about Benjamin enough here in the third person.
Yes.
Let's see if we can.
Let him. He can talk for himself.
Ben, welcome in. Good to meet you.
Well, thank you. Nice to meet you as well.
You're going to be taking us through a presentation here in a few minutes. We're going to take a commercial break before we get to your presentation, and you've got a lot of interesting things to tell us about the AM band and stories of consolidation and just kind of making things right where you need to.
Well, AM antenna systems in particular is something that I learned about from an early age. I actually worked for a consulting engineer when I was a high school student, and that was a long time ago. And for my college radio station, WHRB, and a variety of other strange and odd stations owned by even stranger and odder people. And somehow, this particular nuance of electrical engineering, has been my work area for such a long time. And in recent years, most of my work, although not entirely all of it, has been with respect to AM allocation and antenna systems, because there don't seem to be many young engineers who have much experience in that area. A lot of them are smart as the dickens and know their physics, but they have some difficulty with large pieces of copper tubing that we roll around and play with in AM antenna systems.
We have this impression it's a bit of a black art, but I guess AM follows the rules of physics. It's just that things are maybe a little bit bigger than we're used to when we think about the antenna and RF systems in our phones, right? It's all a different size.
It's all a different size, but it's all the same physics. I mean, everything about electrical engineering and much of the rest of the world has to simply follow Maxwell's equations rules, period. And those rules don't change whether you're at DC or at super high frequencies.
All right. Well, we're going to look forward to chatting with you. And hey, in a few minutes before our first commercial break, both of you, Stephen and Benjamin, we're going to just hit a couple of high points here, things that we're either going to talk about right now or cover in your presentation or after the presentation, kind of during Kirk's Q&A session. Stephen, you mentioned to me there are really only 3 or 4 consulting firms in the U.S. that are truly taking care of AM transmission system design, engineering, re-engineering, analysis, that kind of thing. Why is that?
Yeah, I think a lot of it has to do with the economics of it, and then the aging out and retiring, and a number of our colleagues have gone on to their reward over the years. The people that specialized in AM radio, and so those guys are no longer practicing. And the question of is it a business that you want to get in and grow? And a lot of folks have looked at it and said no, there doesn't seem to be a lot of sense in doing that. So as far as there used to be several dozen firms like ours nationwide that specialized in doing this type of work. Now there's about 3 firms or 4 firms that do this kind of work. as a routine basis. And then there's a number of sole practitioners that also provide services in this realm as well. And there's a number of competent technician type guys out there that are also providing tune-up and other work like that. But it used to be a much larger field, and we're kind of the last people standing in some aspects of it.
So my view may be skewed, but I own a couple of AM stations myself. We've actually simplified them to the point where we went from a directional to a non-directional. But it seems like a lot of AM station owners, and getting some advice from their engineers or consultants like you, they're either some are throwing in the towel, turning in their AM license that just is not profitable for them anymore. Maybe the property that it sits on is worth more. And we're going to talk about that later. Or they're simplifying, like I did at one of my stations, went from 3-tower directional to 1-tower non-directional, and got an FM translator so that we have the nighttime coverage we're looking for. Or so many stations that I talked to several other engineers about this, is consolidating different stations onto the same transmitter site, which can get awfully complicated, but it could really be worth it, especially in light of property values. So, Stephen or Benjamin, would either of you like to just address these scenarios I just mentioned, and maybe there's others of significance that I don't know about?
Well, if you take a look at what I put in the little presentation that I sent you, you'll see that I cover these issues pretty considerably because they're very important at this point. And when it all comes down to brass tacks, every business depends on having an economic model that is positive. And if it isn't, then it's a failure. And the definition of what a failure is can be different depending on circumstances. But basically, if you have a business that doesn't generate enough income to support what it does, then it eventually goes away.
Benjamin, and each one of these situations are unique. You have to stop and pause and do the math on each one and look at all of your options, because there are some folks have come to us and said, hey, we're ready to throw in the towel, and we'll say, hey, did you consider this? And they look at it and go, hey, yeah, we could do that, or that does make sense, or they have solutions that are as equally as complicated and have too many moving parts, and you can solve these problems in more simplified ways. So.
Okay. All right. Well, Benjamin's got a presentation for us. We're going to see that presentation all the way through, where he talks about these different scenarios and how to solve some of them, if not all of them. So that I'm looking forward to that. I have taken a quick breeze through that presentation. I can't wait to have Ben describe the slides as we get on through it. Our show, This Week in Radio Tech, is brought to you in part by the good folks over at Broadcast Bionics and their Camera One system, allowing you to put your morning show or afternoon show, your radio station, your interaction on the web, or if not live, the whole show, at least put the parts that are highlights for social media. Let's take a look at this from Broadcast Bionics. We'll be right back.
Camera One from Broadcast Bionics, designed to bring video to your audio content, visualizing radio and podcasts for social media. Camera One can automatically create, capture and brand professionally switched video for live streaming or upload, making your production shareable. Control and configure using a web browser on any device. Camera One is available as a 4-camera or 8-camera system using the Blackmagic A10 Mini range, including the A10 Mini Extreme. You can use cameras to suit your studio and your budget. You'll need 1 camera for a studio wide shot and usually 1 camera per microphone. A standard multi-channel sound card or IP driver monitors audio from each studio microphone, and we work natively with Axia systems. Ideally, this will be a post-fader feed from each mic, although you can use pre-fade audio or a mic split if that's all you have available. These audio levels are used to intelligently switch the video feed when each contributor is talking. You can also group microphones together into one shot and use the audio from a mixer's aux bus. You can use Camera One's auto switch feature, or disable it and switch using the on-screen buttons or the buttons on the A10. Recordings can automatically start when you tell the system you're on the air. This on-air indication can be linked to your studio's red lights via IP or an Avantec Adam GPIO interface. You can quickly browse all the videos that have been automatically created during your broadcast, download them and post. Camera One is a user-installable system. You'll need a good spec Windows 10 PC, i7 with plenty of storage and 16 gig of RAM. It's better if this machine isn't used for anything else. Remember, you can control the software in a web browser on another device on your network. Camera One, a thrifty way of creating scroll-stopping video from your show or podcast from Broadcast Bionics.
You need to check this out, Camera One from Broadcast Bionics. Go to bionic.radio, bionic.radio, and you can see Camera One and the other offerings from Broadcast Bionics. You like what they have to do? They really help out broadcasters around the world. They do all their experimenting with broadcasters in Britain, and they have got some good shows going on there, so they know what they're talking about. All right, thanks a lot, Broadcast Bionics, for sponsoring This Week in Radio Tech. It's Kirk Harnack in the Telos Alliance studio. It's our 575th episode, second to last one of 2021. Benjamin Dawson is here with us, as is Stephen Lockwood. And gentlemen, I think we need to probably roll right into this presentation. Benjamin, I'm probably going to need to stop you partway through for another message from some sponsors in a little while. But why don't we, Benjamin, tell us a little bit about what we're going to see here in this presentation.
Well, the changing circumstances of the broadcast market have really caused, as you pointed out a couple of minutes ago, people to really think about their AM transmission systems and just exactly what they need to do to maintain them, stay in business, optimize the value, all of those things. And so that's what this little talk is about: the economy, the performance, and the efficiency in the context of the very, very significantly changed market for AM, at least in the United States, Canada, and Mexico.
I'm going to, since we do have 33 slides to roll through, I'm going to ask Suncast, our producer, to give a little quick push on them as we go through, unless it's obvious you're not done talking about one yet, because we do have quite a few topics within the slides. Suncast, let's go on to the next one.
So how's the changing market change the requirements? And here we go.
All right, what's next?
Now, optimizing for performance of an AM antenna system is a very worthwhile thing to do if it's one that produces revenue that's positive. But some systems just need to be as economical as possible to justify keeping them on the air, keeping them maintained, and keeping them running.
Okay.
The considerations that I've outlined here are numerous. The restrictions of FCC allocations work if you want to change a facility. There's the question of whether an antenna meets the antenna efficiency requirements of the FCC. There's a question of whether or not the performance of the antenna is reasonable. If you're modifying or changing a transmitter site for any reason, the cost of that site and the cost of development of that site is significant. The hardware cost of making changes is sometimes significant. Just moving over and diplexing with a neighbor may actually cost more than building a new site from scratch in some circumstances. Then there's deferred maintenance. We all know about deferred maintenance. That's when nobody spends any money on anything and eventually it falls apart. And lastly, but not least in our experience, is the emotion of having to modify and downsize an historically valid, good-performing facility. The FCC's allocations rules are pain, and some of the rulemaking proposals that came out a few years ago would be a very substantial benefit, but somehow the Commission seems to have decided that AM's just not worth the trouble of paying attention to, so they haven't made any significant changes except for allowing AM stations to have FM translators. And of course, amusingly enough, there were FM translators for AM stations before the Commission announced that. There were some in Alaska that we designed years ago.
Oh, yeah.
Now, the significant allocation constraints are the first adjacent channel 6 dB rule, which was put into play back in the 80s, and the long-term effects of the 1 kilowatt power increase for Class C stations, Class 4 stations. Long ago, 7437B allowed people to accept a certain degree of interference to enable a new service in a market that didn't have any service to begin with. Then, of course, there's the fact that if you make a change to a facility pre-sunrise, you often can lose your pre-sunrise operation. And of course, the Commission doesn't allow any increase in received overlap, even though in some cases that would allow improved service and not create overlap to a competitor or to someone else. And then, of course, there's the second adjacent channel 5 millivolt overlap rule, which didn't used to be strictly enforced and was changed back at the same time that the 6 dB rule was changed. Now, some stations are really crippled by the received overlap condition. There's a slide here. In fact, you've missed a slide in here somewhere. But anyway, there was a picture of a couple of contours a couple of slides back that somehow got missed. But it was
so I remember that. I'm sorry, it didn't show. Oh, there it is. There it is. Okay.
Okay. Station on the left has a side overlap by the protected contour of the station on the right on first adjacent channel. And what that means is, go to the next slide, that means that the station on the right was allowed to increase power from 250 watts to a kilowatt without regard to overlap back when they adopted that rule. And it's more egregious now than it was originally because of the change to 6 dB. Next slide. The station on the left can't use a simple antenna even with minimum power. And the station on the right has a little more freedom, but it's still restricted in location and power level because of the Commission's current allocation rules. Next one. Antenna efficiency is very interesting because we can use moment method calculations now to allow restricted ground systems in circumstances that didn't used to be true. Changes in the efficiency rule a few years ago allow simpler antennas to be used. And some grounded monopoles and towers can be used with slant wire or skirt feeds in circumstances where only an existing structure that doesn't have base insulators needs to be considered as an AM antenna. Next slide. What is a ground system? What does it do? Next one. It terminates the displacement current created by the currents in the vertical radiator. Next one. And once again, you've skipped a slide.
Yeah, Suncast said sometimes his button is double pressing even when he's not. So
okay.
Apologize for that. Let's see if there's. Oh, no.
Keep going. One more. One more slide. Oh, well, I'll just talk about it then.
Okay.
The change in the rule, 73-189, reduced the efficiency requirements by 25%, which means that shorter antennas can sometimes be used, and an existing structure that wouldn't have been acceptable might be used. The figure 8 graph that's in the Commission rule isn't based on science at all. We've never been able to figure out where it came from, actually. The electrical height of all vertical radiators is nearly always higher than the physical height. And the 120 radial 90-degree ground system thing is really far too conservative. It's too conservative because it was based on faulty work in the original paper in 1937 because they didn't scale for frequency in their measurements.
Oh.
And so the Commission has now allowed us to use restricted ground systems in some circumstances by using moment method techniques, usually from NEC 4. Next slide. Here we go. This is the conventional ground system requirement. It came from this report here, but like I said, it was an error because it didn't scale properly for frequency because the measurements were made at 3 megahertz. If it had scaled properly for frequency, then it would show you why a restricted ground system at lower frequencies is efficient. Next slide. Is the only real reason you're keeping an AM station to preserve an FM translator? Well, if it is, minimize its cost or maximize the value of its unnecessary or underused assets, chiefly the transmitter site, but sometimes the transmitter building, actually. If it's got a nice, well-built structure, you can rent out space to someone who hasn't got anything to do with broadcasting. And what about all digital AM? We're likely to see more and more of this, and there are now a couple of people operating all digital stations. And it's very interesting because the universal reports of performance are very good. And in fact, the coverage area of digital stations is greater than the coverage area of the equivalent conventional AM station, but it's not really going to become a real driving force until the use of the AM band gets diminished by a significant amount, in my opinion. And we don't have any real allocation standards yet, because no one's done the testing that's necessary, although some of us have been talking about this for several years. John Keane and I have had several discussions on the subject over the years. One of the things that is interesting is the operational powers for all digital operation are going to be less than they are for double sideband AM modulation. And that may make transmitting antenna simplification even more desirable than it is now. We won't have to handle the power levels we do now, although MDCL has done a good job of helping along in that regard. Next slide. So when we look at these things, are there modifications of the site that result in lower real estate costs, or is there a way to change the site in some way or move a site that allows the use of an existing site? Just saw an application by a group owner in the Denver market. They're moving the antenna from one part of the transmitter site to another to allow sale of, or rental of part of the property for building a warehouse. And we looked at a very similar project like that in the Dallas area, in Houston area, although eventually that station ended up getting sold instead. Now, the costs that we consider in these situations can be the real estate itself, the land use and environmental matters, which can be kind of complicated in some case, and is site lease or rental of your site to someone for a different purpose an acceptable and appropriate thing to do. A major site in the San Jose area, for example, for a long, long time, until the station finally moved off the site, was used as a location. Was used as a location for a significant storage area for vehicles, trailers, and boats, and things of that sort. Next slide. Hardware and engineering costs, of course, play into these things. Like I said earlier, we sometimes find that the cost of actually diplexing on an existing facility is not necessarily very cost effective. And other multiple site uses might be sources of rent rather than moving over to another site. And here are some examples. Diplexing, of course. Next slide. Next slide, please. There we go. Here's an example of a cell tower that can be used as an AM antenna by using a slant wire feed, which the Commission didn't approve of for a long time, but which we finally made enough arguments that they've begun to allow slant wire feeds for AM antennas. There are a lot of them in service that were designed back in the 50s and 60s, and they work very well. Next slide. If you're considering any kind of diplexing project and you're going to do any of the engineering yourself rather than send it to a consultant or to Phase-Tech or Kintronic, then you really need to become familiar with Ron Rackley's wonderful paper on the optimization of filter design and implementation. And we did this kind of technique just using a Smith chart for years, but Ron developed this methodology which just uses algebra, and it's a lot simpler to use sometimes. So it's the definitive paper on the subject. And everyone I know who does diplexing pays attention to this paper. Excuse me. Next slide, please. You need to consider uses of the site that don't necessarily require significant facility changes. And that kind of thing is always worth investigating. Sites with extensive buildings, for example, like the Towers Industrial Park, where 1150 and 1020 are in East LA. Some sites with agricultural use, for example, are very valuable. There's a commercial horticultural nursery on a site in the Pasadena area. And we've seen mobile home storage on a lot of transmitter sites over the years, not necessarily even recently. Sites have been used for things like that for at least the last 25 or 30 years that I can recall. And there are other site uses that are compatible. Residential development. Surprisingly enough, we now see residential development around AM transmitter sites, and sometimes we'll even restrict an existing ground system to allow a residential construction. We do have to take some care to ensure that the residential construction is such that the eventual occupants don't experience problems with their electronic devices and ranges and refrigerators. But if it's done properly and done in advance, it's not a big problem. There's a site in Las Vegas like that where the residential development was implemented, I guess 20 years ago, and they followed the design characteristics that we gave them, and nobody's ever complained about a problem. A lot of warehouse structures adjacent to and next to AM transmitter sites or even on the ground system in some cases. There are always, of course, other communications users that can use an AM tower, and if you go about the design carefully, you can make that work very well. And there are places where there are extensive commercial real estate developments for retail and commercial of various kinds on an extensive AM transmitter site. And I've got some pictures coming up with the next slide. Here we go. This is a triplex site in Las Vegas. Look at all those houses. They're carefully situated so that they don't occupy the area of the ground system of the 3 towers that are on this site. As I said, the initial residential development there was about 25 years ago. And when the residential development was completed, the developer told me that he had no complaints from any of the new residents. And I've never heard one since. Next slide. Next one. There we go. This is the Towers Industrial Park in East LA with 5 towers and 2 stations, carefully designed by Brother Rackley, and all the red has analysis was done by our firm, so that all that industrial activity in those buildings takes place without any problem with respect to these 2 50-kilowatt stations. Next slide.
Are those on the roof?
No, they're not on the roof.
Okay.
The towers extend from ground level through holes in the building.
Wow.
If in fact,
oh my goodness.
if in fact it had been developed to begin with as a transmitter site with an industrial use on it, they would have been on top of the building. But because the industrial use was developed after the site was built, the towers were just left as they were, and wells were built around them, shielded wells, I might add. Here's a site on former landfill. This is also a Los Angeles area site, and works very well. The one problem that occurred there was that the landfill settled, and some of the transmission lines had to be reconfigured a bit in order to keep the thing in operation. But that was considered in the initial design. They just didn't realize how much the landfill was going to settle. Next one. Here we go, a commercial nursery operation in the midst of I think this is a 5-tower site, 2 stations, 2 diplex stations and 5 towers. That nursery operation has been there as long as I've done work on that site, and I think the first work I did on that site was about 40 years ago.
Wow.
Next slide. That's a very compatible use, by the way. Yeah. This is KTAR in Phoenix. You have to really look to find the towers on this site. This is a 2-tower directional antenna system on 620, and the number 1 tower is pretty tall. Number 2 tower is not quite so tall, but it's perfectly compatible. I think it's a Walmart and a Home Depot, if I remember correctly. And except for the fact that we had a contractor a few years back who dug a ditch and went through one of the transmission lines. You know how it is. It's backhoe fading, as they say in the microwave world. We've never had a problem with this facility. It's worked beautifully and meets the proof of performance requirements with no problems. Next slide, please. Deferred maintenance is really interesting because it's perfectly valid to employ deferred maintenance under some circumstances if the long-term revenue is less than the maintenance cost and the facility is going to be discontinued or abandoned at a reasonably certain time or reasonably certain event in the future, then deferred maintenance can be really beneficial, but it has to be done extremely carefully. One of the things I sent Kurt for you to figure out how to get to people if they want is a little 1-page shootout I wrote years ago on deferred maintenance based on what the railroads and the electric utilities use, and they pay close attention to this sort of thing. So deferred maintenance can really be a a real bugbear or it can be a real benefit, just depending on whether or not you're paying attention. Caution is necessary. Next slide. That gives you the rationale for why deferred maintenance can be used, and that it doesn't mean zero maintenance. Next slide. Emotion can be very important. We've seen a number of our clients and friends who just almost had heart failure because they had to give up a well-performing, good coverage facility for good, solid economic reasons. But short-term emotion isn't a useful path to long-term valuation. I mean, it pains us all greatly to see a really fine old facility abandoned or downsized or discontinued sometimes. I mean, the guys who built that, were careful and did a good engineering job and built beautiful facilities. But Studebaker used to build buggies too, and then they built cars, and then they had to get out of the business. And some radio stations are just like Studebakers. In fact, sometimes as a person who does a lot of AM antenna and allocation work, I wonder if I'm just like the last buggy whip designer at the Studebaker Brothers wagon factory.
Oh, goodness. I think do we have one more slide? Yeah, there we go. There's the references.
Well, that's a set of references. I think at least one or two of those are on our website, but a couple of them aren't. So I sent them to you, Kurt, so that you can figure out how to pass them around if people would like them.
Yeah, I will have links to those on the show notes for today's show, so that people could get those. I'll store copies of them on my website or on my server, and folks can click and get a copy of that. Wow, Benjamin, this has been terrific, and of course, I've got a lot of questions to fit. I want to let you get through that so we could get through it, and then I've got a lot of follow-up questions, and I'm sure Stephen can participate in this too. Tell you what, that was a lot of info pretty quick. We're going to take a quick breather and hear from one of our sponsors, and Benjamin and Stephen. When we get back from that, I've got questions and maybe those questions will bring up some more discussion. So this week in Radio Tech, I'm Kirk Harnack, Benjamin Dawson, and also Stephen Lockwood with Hatfield and Dawson Consulting Engineers are our guests on today's show. Our show is brought to you in part by Broadcasters General Store and the Broadcast Tools Pro Mix 4. Now, this is an interesting little audio console. One reason it's interesting is because it's mono. It's not even stereo. Now, why would you buy a mono audio console? Well, I'll tell you why. To do voice tracking in a little studio, to go out on remote broadcasts where you have several announcers. Maybe you've got a play-by-play person and a so-called color person to provide stats and interesting information. Maybe you've got a field reporter and you can bring them in this way. The ProMix 4 is a compact and full-featured mixing console, and it's good for any broadcast studio as well as remotes. It has 3 combination mic line inputs, and then it has a dedicated 4th input that can be switched between that balanced line input, or it can get audio from the built-in USB audio interface, so it can grab audio right off your computer. It has 3 quarter-inch stereo headphone outputs, and they have individual controls for volume, mix, and pan, so you can have custom headphone mixes for IFB versus hearing the other people that are on your broadcast. Other features include a switch-selectable program limiter. So if you have a loud announcer, no problem. Put that limiter in line. It has an XLR program output to go feed, a Marty transmitter or maybe some codec if it's not your computer. You can monitor the output with muting. The monitor output has muting and volume control, and you won't find that on little, little mixers like I'll, mention a name like Behringer or, things like that. You're not going to get a muted output. And it also has an on-air light relay output. So yeah, you've got a broadcast console here that just has just what you need for certain functions. Check it out from Broadcasters General Store. The way to get to Broadcasters General Store, go to the website at bgs.cc. bgs.cc at Broadcasters General Store, and they'd really like you to call them. In this day and age, hey, maybe you're the kind of person that likes to go to a website, and I am too, and they've got a website, but you can also call them and talk to a real person. And any of the family there, it's just great to talk to. And when I say family, I do mean family, plus people they've brought into their family over the years. Buck Waters, practically a member of the family there. Hugh and Jonathan. Well, I think Jonathan is a member of the family, but there's you give them a call at 352-622-7700. 352-622-7700 for Broadcasters General Store. Great folks, all the broadcast gear you could ever shake a stick at, and at good prices too. Say, hey, I need a sharp pencil on this, as usual. Let me have your best possible price, and they'll give it to you. All right, thanks a lot, BGS and Broadcast Tools and the ProMix 4 for sponsoring This Week in Radio Tech. I'm Kirk Harnack, along with you, and we are talking with Stephen Lockwood and Benjamin Dawson from Hatfield and Dawson. Benjamin has just run us through a terrific, quick too. I mean, we got a lot of information there quickly. I've got some follow-up questions. First one that I took some notes on here was about all digital AM. Certainly, we've known about the one and now two stations that are all digital on AM. You think this can take off? It seems a science experiment for now. A couple of stations where it was kind of prime to go with. And if it is time for more people to do all digital, how does that change the AM transmission landscape with regard to protection contours and coverage areas and things like that? Who wants to take that one?
Well, as I mentioned, a number of us have had conversations over the years, last 10 years or so, about changing allocation standards so that they allow all digital and AM, ordinary double sideband AM stations to be adjusted, allocated with respect to one another. And we haven't seen any action from anybody, at least all from the FCC. The one country that has put in a lot of all digital using the Digital Radio Mondiale system is India. And they, of course, did it with a state broadcasting entity, which does its own internal analysis of allocation circumstances. And we don't really know what those were. But reportedly, their performance is very, very well accepted. And there are local manufacturers there for DRM receivers. Eventually, that sort of thing will happen in this country. And of course, your automobile receiver that is designed to receive the Ubiquity system will receive the all-digital signal as well from the Ubiquity all-digital signal that's being employed here in the U.S.
Right. Okay. Let's see. I'm trying to read my notes here. So I was writing pretty quickly. Oh, yeah. You were talking about land uses, and I think that's pretty interesting. I've certainly have been to the transmitter side of WSB in Atlanta, where they have shopping, commercial, shopping all around that transmitter site, and lots of parking lots in close to the tower, and then shopping and retail further out from that. I know at the WLW transmitter site, just north of Cincinnati, I believe they have retail. Residential and retail that's coming in onto land that was formerly all ground system. You mentioned storage of trailers. I was thinking, sometimes you drive down the highway and you see a huge parking lot that's just full of new cars that are there for storage, haven't been moved out to dealers yet. Obviously these are great compatibles. The nursery, the RF is not going to bother the plant so much. Let's talk about that a minute, Ben or Stephen. What do you?
Yeah, I think there's some wonderful uses that we can put on AM station land and not cause any problems. Any storage like RV storage is something we see a lot here in the Pacific Northwest, where you've got a number of people that have an RV and they use it maybe 2 weeks a year, and they don't have any place to park in their neighborhood, or their neighbors are cranky and don't like it out front. And so RV storage is a big thing around here, and that's a perfectly wonderful thing to put in an AM station, over the ground system, and just as long as the land is appropriate. And if you need to put in blacktop or any other issues like that, you can do a lot of work right over the ground system and not cause any problems. So that's wonderful thing to look at. We've looked at a lot of folks call us and ask us questions, and one of the things that keeps coming back is self-storage facilities, and this is the case in most urban areas. Self-storage facilities are big buildings with nobody home in, and so they do have some advantages, but there's some things you need to pay attention to when you do this kind of development. And if there's questions on that, we certainly can help you on the back end. But the simple addition of those kind of things on sites are just a wonderful use and a great revenue stream. And the other thing that we've noticed, and Benjamin sort of alluded to this, is there's a lot of stations that have what I like to say 3 dB more dirt than they need. So if you look at the land that they have, they're using really only about half of that land for their broadcast facility. And there's just you look at the value of the land and say, well, there's something else that you could do here, and that land can write a very nice check. And so there's some things that before you turn the lights out, let's look at your facility, look at the land, look at all of the options, and say, hey, is there some way we can combine the usage here and make a little more revenue off our existing assets?
What you want to watch for is,
yeah. I'm sorry. Go ahead, Ben.
What you want to watch for is you want to make sure that whatever use you're trying to see if it's compatible or not, how much vertical aperture it takes up. I mean, you don't want to build something on a site that's 11 stories tall, that's within a quarter wavelength or an eighth of a wavelength of your antenna tower. I recall once making measurements on an old antenna that had buildings built around it off in an island that I won't name, and the effect of those tall buildings, steel in those tall buildings, could easily be seen if you measure the impedance of the antenna. But there are an awful lot of uses. Solar arrays are another thing that we can put on AM transmitter sites without, once again, it has to be properly engineered, but it can be done.
Good points. And back to that land, I guess a lot of AM tower sites, the land was purchased based upon the parcel availability and the size and shape of the parcel that was there, with plenty of room for your ground system, and maybe a station owner could subdivide that land and carve out the places that aren't really necessary for the ground system. After all, or as you mentioned, I don't know if you used the word foreshortened, or a ground system that wasn't, as substantial as was originally designed to be. Tell me about any problems with doing that, with foreshortening your ground system to sell the land.
Well, if you're, go ahead, Steve.
Yeah, I was just going to say all of that can be modeled. So one of the things that we can do now with NEC 4 is actually model a trimmed ground system and see how much that affects the efficiency of the antenna. And often we find that it's not as big a deal as you would think it would be. And these are things that have been confirmed with measurements as well. But those are some things you can do. Also, one of the items as one moves forward with this kind of stuff is you can give people get an easement for that ground system over whatever they're planning on doing. And so if they're planning on a parking lot there, then an easement for a ground system underneath their parking lot is a perfectly reasonable thing to do, and is no skin off anybody's nose. So.
Benjamin, you mentioned don't build any tall buildings. I would imagine water towers would be a bad idea as well.
Well, the water tower is kind of different than a building, because a water tower can be detuned pretty nicely, particularly the ones that are a bulb on a stick. Because if you hang down vertical wires from the envelope of the bulb itself down to ground level, you've created a loop which has a large area and therefore has the ability to be tuned very nicely. And so we've seen more than a few nice water towers that were real close to AM antenna systems, maybe across the street or something, that we've been able to detune very nicely. So a simple structure like that is a much different thing than a complex building with steel structure within it. So, every case is different, and so you really need to look at them on a case-by-case basis. But there are lots of things that can be done that people in times past never really were comfortable doing.
Earlier, you brought up the slant wire feed. That was early in your presentation, Benjamin, and I take it that you're speaking of being able to use someone else's tower that may already exist, especially maybe a cellular tower, by giving it a slant wire feed. In my engineering career, I've really only seen one slant wire feed in the U.S. That was in Kentucky. Worked fine. It had obviously been put in back in I think in the mid 60s, maybe earlier. And then I did see a slant wire that was added to a tower on the island of St. Lucia in the Caribbean. And it was being added in order to somewhat directionalize the existing tower there, the existing AM tower. Talk to me a bit about slant wire feeds, pluses, minuses, and how useful they can actually be.
Well, I've always been a proponent of slant wire feeds because the second radio station I ever worked for when I was a high school student had a slant wire feed designed by Harold Singleton, PE, who was the consulting engineer I worked for when I was a high school student. And it worked very well. There were a lot of them around the Pacific Northwest because all the consultants around here, Jim Hatfield Sr., Grant Fikert, Singleton, let's see, who else? Fellow down at, well, anyway, they all built various slant wire systems. I wrote a paper about this a few years back, and I gave some examples from here in the Northwest mostly, although there are some, in other places all over the world. There are actually quite a few of them in the United States, and there have been a few slant wire fed directional antennas. There's only one still in service. That's KOAC in Corvallis. It's worked beautifully since 1938 or 39. So it's an excellent technique, particularly for towers that are shorter than about 120 degrees or so. And our modeling shows that the performance of those antennas, is just hard to distinguish from the performance of an insulated base-fed tower. And we prefer them in many cases to a skirt feed because they don't add very much, almost negligible additional physical load to the tower. A skirt feed has to be either tensioned or have enough insulators in it so that it doesn't flop around in the wind. And that tensioning or those insulators add, structural load to an antenna tower. A lot of them have been put up without consideration of the structural circumstances. And of course, in either tropical climates or in Arctic climates, the weather can do in a skirt feed pretty fast. So I've long been a proponent of slant wire feeds, and so I'm very happy to report that the Commission has finally relented and allowed us to use them.
And what has had to happen for the FCC to approve these is we've had to do a moment method model that would compare the high angle radiation off the tower to the standard base fed tower, and demonstrate that there is no fields that come off of the tower that exceed the standard base fed tower, and that's really all that we've needed to do to make the FCC happy with that, make sure that it still colors within the lines, as it were.
Stephen, I was just reminded you sent me a short movie clip that we'd like to look at. This was pretty interesting, and it's always a little exciting to see some arcing going on. You want to set this movie clip up before we take a look at it?
Yes. As folks have moved in on AM stations, because of the land use side of things, we've had more and more construction happen, adjacent properties and various things like that. And, we get a call probably a half a dozen times a year now from a construction firm that's having issues with their cranes and having problems that they can't solve. And so this clip here was taken in Hayward, California, right across the street from two 50 kilowatt stations, and they're building a combined cycle gas power plant. So it was a big construction project right there in Hayward, and we quickly got a call from these folks wondering why the voice of God was coming out of the pile driving equipment, and why there were arcs and burns and shocks. So let's show the clip now.
All right,
we need some audio off of it. Yeah. Now the strap is hooked up to the fence in the background, And this is a 200-foot.
Everything I put into print, I have to write out in, or I can't make it fit. It's just a process I go through.
That's called an ionic switch.
Ring finger. My hand, it was sore as a boil.
So that's the audio coming out of the arc, and it was particularly humorous at this station because at 7 a.m. there was a what tended to be a fire and brimstone preacher on that station, and the construction workers, when they were doing the pile driving issues, they had rigs hanging down from that. When they'd drop on the ground, they would hear the voice of God coming out of the ark and tell him to mend their ways and stand up straight and stop mumbling. And so it was a kind of a humorous little thing. But we were able to come, and we've developed some safety courses that we can work with your standard construction folks and teach them about this issue. And most of the time, in fact, we don't even recommend it. There's a lot of concerns about detuning some of these towers, but these cranes. And the answer is it's really not worth the trouble because they're going to be moving around, and the construction process may take 6 months or 2 years, but they're going to be moving around. You can get them to lower the cranes at night, but in general terms, there's some safety protocols that they need to follow and some issues that they need to understand, and we can help through that if they need to go through that. But the short answer is don't touch the crane hook. And so once and most people don't do it a second time, and but it's been good fun.
For permanent installations, you can buy a insulated hook, which is made by a manufacturer in the Bay Area to U.S. Navy specifications, because the insulated hooks that are for power line use don't have very good RF characteristics, but the ones manufactured to the Navy specs do. So if you have a permanent crane installation and you need to have or you can use actually Filostrand manufactures Filostrand rope specifically for crane use. I mean, it's not just guy wires. So you can, if you have a certain size of cranes, you can get Filostrand cable for your cranes as well.
And I just want to clarify the movie that we saw, Stephen. The copper strap you said was hooked to a fence. I mean, was it effectively? Yeah, was that the ground?
Right, that was effectively the ground. And even if you walk up and touch that crane hook, you're going to be grounded through your feet. Exactly. And so that current is flowing through you. Now, there was a situation a number of years ago in the Port of Seattle where we did extensive science on this project, and we had a crane that was in a known position, and so you could walk out with a shackle and touch the end of the crane hook and then get that current flowing. And we had a clamp-on current probe that would snap around your arm, and you'd see how much current is flowing through you. And at those situations, as long as you had a good grip on the shackle and you didn't have you had a lot of surface area. And I took a turn because I'm that kind of guy, and the amount of current that I had flowing through my arm, it was 1 amp of RF, and you look at that can be a significant issue. The real problem here is the shock and burn, and you look at it and go, well, okay, I get a little burn, and a lot of us who work on AM, we get shocks and burns pretty regularly. We shut the station we're working on off and make sure everything's careful, but sometimes we forget about the guy down the street, and and that can make things a little exciting. But the real hazard around construction sites is the startle effect that would happen if somebody walks up and touches something that has this and takes a big giant step back into a pit of rebar or falls off something, and that's a real hazard.
And by just to get an idea of the sizes and spaces involved here, that crane where that hook what we saw with the arcs, how tall would the steel cable have been? How tall was the crane?
Yeah, the crane was a 200-foot boom, so it had 200-foot boom, and then dropped that cable down. So do Pythagorean's theorem there, your trig. But you've got this loop that is intercepting all of that AM energy that's coming through there. Yeah. And if you were going to design an antenna to intercept as much AM energy as you possibly could, It would look remarkably like a construction crane.
Yes. Yeah. And then how far away were the AM transmitting tower or tower?
They were about 800 meters, so they were just right across the street from this site. So it was very very close in, and it can provide exciting things. Now, what's interesting to us is to watch folks come in and try to solve the problem, and they'll go through all sorts of grounding efforts and things like that, and sometimes they trade one hazard for another. So you got all these extra ground rods that you've driven in all over across the site and created trip hazards. But you've also, when you ground that antenna, the antenna, yeah. And you've end up making it a more efficient antenna. And so you actually, from a arc hazard at the end of the crane, you actually make the problem slightly worse. And we've made extensive measurements on this. It's good fun science.
Of course, the easy thing to do is turn the AM station off the air, but that's probably not a good solution either.
Well, do you have a checkbook? We can talk.
Well, now there you go. If it was a time brokered station, I guess the construction project could say, how much is 8 hours a day on your station? Well, it's $10,000. Okay, here's $10,000 for each of the next 5 days. Turn it off.
Yeah. And we were in situations on some of these construction sites, and we've had a number of them where there would be like a critical lift where they were bringing something in that was very large and required 2 cranes and lots of moving parts and pieces that were very expensive. And this was the way it was at the power plant. And so those days that we were in that situation, we had them reduce the power and kind of cooperate with that process to make that a little more simple issue and not have to worry about that issue while they were putting in the piece of equipment that was rather expensive. But but it is an interesting thing also in all of these situations is in the power plant we had really a lot of fun with radio frequency interference issues there and a lot of work through some of those issues and it's just the standard issues you go through when you're solving radio frequency interference problems and just work the problem.
We had one great advantage on that project, and that is the safety engineer, who was a real engineer, a civil engineer as it happens. The safety engineer for the project was a radio amateur. And that meant our explanations were a lot more favorably received than if he'd have been a person who didn't know much about RF.
Your explanations did not fall on deaf or confused ears. At least you had an audience.
Right.
Indeed.
Yeah. Good deal. Hey, we got a tip of the week coming up. Of course, I forgot to tell Stephen or Benjamin about this, but when we come back from our last quick commercial break here, we want to hear a tip of the week or two, one from each. So I'd like to hear something to walk away with. This Week in Radio Tech is brought to you in part by my friends at Angry Audio. Angry Audio owns the whole Studio Hub line, and they've come out with a new product at Angry Audio and Studio Hub. It is this World Panel. Now, World Panels aren't new. World Panel is something you put in your studio so that anybody coming into your studio that needs to provide some audio into your console or get audio out of your console can plug right in safely. And they can have let's say a no hum, no buzz, no ground loops. They can get great audio in and out of your console. Maybe a TV crew comes in. This is one of the most common uses. You have a TV crew come in and they want to do a story. And you want good, clean audio of your radio station feeding the TV camera recording or whatever. So a World Panel often does that, but so many World Panels are simply passive devices for audio inputs and outputs. They're just a panel of connectors. Well, this panel from Studio Hub is different. This is an active and buffered panel. It's going to give you great audio. It's also going to provide you protection of your equipment in case the TV station or somebody comes in and plugs something in and who knows, they've got 110 volts on their XLR connector. They shouldn't be that way, but you never know. It's got balanced and unbalanced connections here. It also has a 1/4-inch tip ring sleeve and XLR connections. It all for analog or AES-EBU digital, mono stereo, and in case you want, it gives you a pass-through here of Ethernet. If you've got AOIP, if you got some used to bring that out, you can bring that out as well right there. So check this thing out. This is, and it's got a place for the power to go in back here because, like I said, it's buffered. It's not a passive panel. It is actively buffered. Check that out. Brand new from Studio Hub. Go to their website at angryaudio.com. Look for the whole Studio Hub line. And of course, you can get all the cable adapters from Studio Hub that you need to finish your project without having to do any soldering and splicing. You can just, use these great Studio Hub adapters. angryaudio.com is the website. Thanks, Angry Audio, for sponsoring This Week in Radio Tech. And you know our other sponsor that we have on so often, Max Connect Wireless, to get you a fixed IP address and data when everybody else's kind of doesn't work. Here's John Takach to tell you about Max Connect.
With all of the recent cybersecurity attacks against large corporations, we were looking for a product that would give us the ultimate security at our transmitter sites and as well as with our broadcast equipment. Max Connect fits the bill very well. Its greatest security feature is the fact that it gives you a single static IP address. Using this single static IP address allows us to close hundreds of open ports on our firewalls across the company and restrict access to only the Max Connect IPs. This has greatly reduced our exposure to the World Wide Web and made us much more secure moving forward. It's also given us the ability to expand as needed in a secure fashion.
Check it out. Josh Bone has developed Max Connect Wireless, giving you prioritized 4G LTE data using the Max Connect Wireless Network. It's Max Connect. I know it's spelled funny, 2 X's and a K. We'll have a link in the show notes so you can connect up to Max Connect Wireless. There you go. There's the website at maxconnect.com. All right. Thanks a lot, Josh Bone and Max Connect, for sponsoring This Week in Radio Tech. A lot of engineers are finding it quite valuable for remote broadcasts and access to remote transmitter sites. All right, we got just a couple of minutes left, and Stephen and Ben, maybe you can leave us with a word of wisdom or a tip of the week. What you got?
Well, I just suggest folks doing their homework. Look at your AM sites and kind of work the problem. And there's some resources out there. Certainly talk to some of your local real estate mongers to look at some options on your land and what things could be done. Look around what's happening in your neighborhood. Do you need a Quickie Mart on the corner? All of those kinds of things. Work that problem and look at the options in the market of what you're doing. But there's some opportunities out there to maximize resources there for you.
I believe so. I think of so many AM transmitter sites that started out, way out in the hinterland, and now they're surrounded literally by, in my neighborhood not my neighborhood, but down the road, literally $1 million homes around the transmitter sites, and they would love to have another avenue or lane or cul-de-sac going in there, and there's room to do it. Benjamin, I'm sorry, what were you going to say?
I was going to go back to the basics for a moment, and that is we still see a fair amount of AM antenna systems that have stability issues. And sometimes those stability issues are the result of lack of maintenance. And so my suggestion to people is the next time you really do a whole day-long inspection of what's going on at your AM transmitter site, in addition to getting rid of the brush around the towers, in addition to just cleaning up, make sure that the ground connections between your antenna tuning unit equipment and the tower base grounding that connects up to the radios, make sure that those are really secure. And when we design new systems or rebuild a system, I always recommend 3 parallel straps from the corners of the equipment to the corners of the ring around the tower base, because that's an extremely low impedance connection. And that way, the next time it rains, it won't throw the phase off on that tower by 10 degrees.
Mm-hmm. Great advice. That's super advice. Yeah, I like the parallel connections. Yeah, good deal. Gentlemen, we got to go. Thank you so much for taking the time to share your knowledge and wisdom with us and some ideas on how to maybe even profit a bit from your AM station in a non-traditional revenue, let's call it, and keep it working well. Benjamin Dawson, Benjamin Dawson with Hatfield and Dawson, and also Stephen Lockwood. Hatfield and Dawson have been our guests. Our producer has been Suncast. Thank you very much, Suncast, for taking care of us. And also thanks to Andrew Zarian, the founder of the GFQ Network. Tell your friends, please, about This Week in Radio Tech. We got one more show this year, got a couple of special guests coming up. A friend of the late Chris Tobin, Sam Wu, will be our guest, along with, Chris Tarr is going to be with us next week. So stay tuned for that. We'll see you next week. Merry Christmas. Happy holidays to you, whatever you celebrate. Look forward to seeing you next week on This Week in Radio Tech. Bye-bye.